Okay, this is number 15 on the Chapter 1 condensed worksheet. So we're doing PEMDAS here because it says simplify. And if you remember with PEMDAS, the first thing we do is we take care of parentheses. Well, we have two sets of parentheses here. One of them is this one I'll highlight in red. And then we have another one, and I'll highlight it in green. These are also parentheses, right? So we always start with the innermost parentheses. And when we get inside of a parentheses, you really got to start thinking about PEMDAS again anyway. So as we look inside the red parentheses, I'll do that first, you see that you've got some exponents and you've got some adding going on. Well, PEMDAS would say do the exponents first, right? So inside of there, we'll do the exponents. 2 cubed is 8. 2 times 2 times 2 is 8. It's not 6. And then I'll put the plus sign down. 2 squared is 4. Well, we know that's going to simplify. 8 plus 4 is 12. So here's what we have now. I'm just going to recopy. We have 3 cubed minus all of that inside the red parentheses ended up being 12. So I'm going to make it red just so you remember that's where it came from. Okay. And actually, let me draw my brackets in green just to show there's where my other grouping symbol is. Okay, so I still got to work within the grouping symbol or the parentheses, even though it's not a parentheses. Okay, so inside of there, we got to think PEMDAS again. Every time you go inside a parentheses, you got to kind of rethink PEMDAS, and you would do exponents first. So 3 cubed is 27. So let's see. Let me put my equal up here. I should have done that. 3 cubed is 27 minus 12. That's in the green parentheses. Still got to finish those before I do anything else. But let me go ahead and copy down the divided by 5 so I don't forget about it. Keeping up with the extra stuff's important, and that's where a lot of people go wrong, okay? Now, 27 minus 12, of course, is 15. So now I'm down to 15 divided by 5, which is going to be 3. So that's how we would do that one. Okay, I wanted to also work number 17. If you look at this, you still got to think PEMDAS. The thing about PEMDAS, the P may stand for parentheses, but it's really any grouping symbol. And we do have a grouping symbol here. As a matter of fact, we got 2 grouping symbols, if you think about it in a certain way. The first one that we notice are these absolute values. That's just saying I'm going to calculate everything inside of there, and I'll take the positive value of it, because remember, distance is positive, okay? But even inside the brackets, a fraction bar really stands as a grouping symbol. It divides the top and the bottom into 2 separate parts, and you have to do the whole top before you do the whole bottom. And that's one thing that people, when variables get in the mix, that get all confused about and try to cancel things that won't cancel. So anyway, let's try working on this, okay? So I'm going to work inside the parentheses, the absolute value signs. I'll just draw them like this time. And then inside of that, I still got to think PEMDAS, and I got another grouping symbol, and it's the fraction bar, so let me write it down. And I got to do the whole top and then the whole bottom. Well, on the top, let's do it first. I have 1 plus, I got to do the exponent first before I can add, so I just wrote down my 1 plus, but 7 squared is 49. And on the bottom, we've got 5 squared is 25, okay? Well, oops, see if I can, well, we'll have to just ignore that. I have 1/3, and on the top we get 50, and on the bottom we got 25. Still working within that grouping symbol. Well, 50 divided by 25 is just 2. If you get confused about whether it's 1/2 or 2, just think about it as reducing a fraction. 25 goes into 25 once, and 25 goes into 50 twice. Well, the absolute value of 2 is just 2. So what I really have is 1/3 times positive 2, which is 2/3. Can't read that. Let me write it over here, 2/3. That's my answer there. All right, now looking at number 20, we have this expression, and we're told to evaluate it, and we're given these numbers off that I've written to the side up here in the corner that we're supposed to plug in. So all you got to do is plug it in, and then we'll be doing PEMDAS. So really, this is just another PEMDAS problem, but you have to put the numbers in the right spot. It's like plugging numbers into a formula, in other words. Okay, so let me make, what I like to do when I'm doing this sort of thing is make spaces for everything, just so I make sure I got it all. We have z minus x, so let me put a minus sign there. All right, I'll do the x's in green. X is 3. Well, that's here and here. I'll do the y's in blue. Y is 2. Well, there's a 2 here, and then we have to put a 2 here. And then I'll do the z's in red. We got a 5 here. We got a 5 here. Now, I got to think about PEMDAS. Plugged everything in. I got to simplify it. Each fraction I know is a separate thing, okay? I don't want to be, trying to, I kind of got to look at that as a fraction's a separate thing. But even within each fraction, there's a grouping symbol, and I'll highlight it. It's the fraction bar, so we do the whole top first and then the whole bottom of each one. So I go to each fraction knowing that it's got 2 parts in it, but then I got to say, okay, I still got to think PEMDAS within each part. So if you look at the top of the first fraction, it's got an exponent on it. Really, that's all that's going on there anyway. But we would do the exponents first, so I'm going to do that in both of them first. 5 squared is 25 on top. And then over here, 2 squared is 4. Okay, now I could copy everything down, but since we've got fraction bar as a grouping symbol, let's go ahead and try to make the most of, so we don't have to write so much. If I look on the bottom of the first fraction, all I got to do is add. 3 plus 2 is 5. And then on the second fraction on the bottom, all I got to do is subtract. 5 minus 3 is 2. Okay? Well, pretty much when you get to this part, you're probably okay, but just remember each fraction is its own little thing, so we don't want to go saying 25 minus 4 is 21 and 5 minus 2 is 3. That would not be right. Remember, you could only do that if you had a common denominator, but we don't need to go to that much trouble here because 25 divided by 5 is 5. If you have trouble with that, think of it this way. 5 goes into 5 once, 5 goes into 25 5 times, 5 over 1 is 5. You're still struggling with what you're supposed to do. If that was 5 over 1 or 1/5, you need to get that straight, okay? Now the second fraction is 4 over 2, which is 2. It's 4 divided by 2. We read top to bottom. 2 goes into 2 once. 2 goes into 4 twice. 2 over 1 is 2. If you needed to do it that way, you could. Well, 5 minus 2 is 3, and that's all we got to do there. Okay, the thing about absolute values is you have to remember that each absolute value sign on number 22 is a different grouping symbol. And so you got to almost look at it as a special kind of parentheses. Well, let's first go plug our numbers in. Okay, my A is 6 and my B is -2. Didn't almost leave myself enough room there, did I? Okay, so the thing about this is, if you look now, the next step we would do is say, okay, well, each absolute value is a grouping symbol. So the absolute value of 6 is 6. And I'll square it in a minute, but I'm doing the grouping symbols first. The absolute value of -2 is actually 2. So I'm going to write that down, but I've still got to square it, okay? Okay, so we did our grouping symbols. The next thing we should do is exponents. 6 squared is 36. 2 squared is 4. I'm supposed to subtract them, so I get 32. Okay, I thought I'd do 39 just to remind you about some things about distributing. Remember, you can always watch a video on one of them and then go back and try the others using the principles talked about in the videos. All right, I'm supposed to do grouping symbols first, but if you look, there's 2 parentheses. If you look inside of them, there's nothing that goes together. We can't simplify inside the parentheses. So we know that since each parenthesis has a number out front, what we're going to do is we're going to distribute, okay? We don't need to distribute on the first parentheses, though. There's no number out in front. I misspoke when I said both of them had numbers out front. So you know what? I can just write this down. It doesn't need to be in parentheses anymore because, it's just there's no negative out front or anything that's going to change those values. But on the second one, I have a -2 out front. Now, if you remember, a -2 or subtract 2, I can look at it as multiply by -2 because I could rewrite that subtraction sign as plus a -2 times all that stuff. So that's what I'm going to do. Instead of having a subtraction sign and just distributing the 2, I'm going to work more efficiently and distribute a -2 as I distribute. So -2 times -2x would be a positive 4x, so I will write plus 4x. A -2 times a plus 3y, -2 times 3 is -6, so I'll write it as minus or subtract 6y. And then -2 times -3 would be a positive 6. Now all I got to do is combine like terms. Okay, so let's go looking for like terms. I've got 6x here and 4x here. That's 10x. I'll just write each like term in a different color. I've got a minus 5y here and another minus 6y. If you remember what we do when we combine like terms is we write the term down, the y down, And then we just add the numbers out front. So you're thinking of this like -5 plus -6 is -11. Or -5 minus 6 is -11. Remember, you can think of things as adding a negative or subtracting. It's the same thing. However, it's easiest for you. And then we got numbers 4 and 6 add up to 10. And we're done.